Hey everyone, before we get started on today's episode, I wanted to tell you about another podcast Melissa and I are loving these days. It's called As a Meter of Fact with CoServe. It's hosted by a friend of mine, Jason Kress. He's been a guest on our show before, and you may also know him as the co-host of my other show, Podcast for Your Life.
As a Meter of Fact helps people become smarter energy consumers, and you know from our episode about the climate that we really care about that a lot. This podcast has science, humor, ways to save money and energy, basically everything you're looking for in a podcast.
I like their episode about staying cool in the summer months. It gets very hot here in Texas. They share some ideas and tips that I'd never heard before, and I found them really helpful.
This show is for anyone whose house is powered by electric or natural gas. That's pretty much everyone. So more specifically, this show is for you if you live in North Texas, if you're a CoServe customer, or if you want to see how local utilities can be fun and entertaining.
Subscribe to As a Meter of Fact with CoServe wherever you listen to your favorite shows.
Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
Okay, Jam, I'm not sure how you're going to feel about today's topic.
Okay. I guess I'm not sure either at this point.
So we're going to be talking about how bath bombs work.
Okay. I've never bath bombed, but I have bought a bath bomb for my wife before.
Okay.
So there's a little connection.
Yeah, that's your connection point. I did know that Emily likes baths.
Mm-hmm.
So I didn't know how you'd feel. I didn't think you were a bath kind of a person.
I'm not. Yeah, I'm not really. I don't know if I'd be against it. It just has never crossed my mind as something I want to get into. But, you know, M takes the baths in our household, so I have an investment in them.
Okay. All right. So have you ever seen the bath bomb go off? Like, has she put it in the water in front of you or something?
I kind of feel like I have, but I don't have a clear memory of how it works. Maybe I've even seen videos or something. I don't know. I just feel like I remember seeing like a lot of fizziness happening and like cloudiness coming out and emanating from the bath bomb.
Yeah, that's right. It's just a fizziness that emanates from the bath bomb and it kind of swirls around in there, letting all these bubbles and colors and good smells go.
Okay, nice. Oh yeah, good smells. There we go.
Yeah, good smells. I have good smells in them, usually. And sometimes they have sparkle, sometimes they have colors, sometimes they have moisturizing things in them.
Do you ever play songs or anything like that?
I don't think so, but sometimes they do have little surprises in them.
Right.
And sometimes they have a insert in the middle. So your outside bath bomb is one color, and then you get to the middle and it's a new color.
Interesting. This is crazy. I wonder who thought of this kind of stuff. It's like,
I have no idea.
Interesting to spice up the bath. It's kind of a normal thing a bath is.
Yeah, they get them a little more exciting. It's like bubble bath. Elevated, an elevated bubble bath kind of.
Right,
because
right.
But I don't think they don't leave bubbles behind after they've gone off. They just leave your water kind of like a color usually.
Okay, got it.
So that's the bath bomb. If you have never used one, I encourage you to go look it up on the internet and watch video or something real quick. So with that in mind, and using all the things that you've learned from chemistry in this last year and a half that we've been doing this, I want you to try to think if you could possibly come up with something, and I want listeners at home too to think about it.
Okay.
And see if you can come up with something that would release bubbles or fizz like that.
Okay, let me think. So I feel like the bubbles could easily be carbon dioxide.
Mm-hmm.
And there's oxygen in water. So it could be that it reacts with it and that makes it if it's not already there.
Okay.
But the thing it would be that would react with it? Okay, I'm trying to think of some of the past, like, kind of highly reactive things we've talked about with some simple ingredients. So, Mentos and Coke, there's a lot of release of stuff that's already in there, and it's speeding up the process in that case.
Yeah, definitely.
And then we've talked a little about vinegar and baking soda, and then also kind of baking powder, the acid and base reaction of stuff. And so I feel like that could be at play here, although water itself on its own is supposed to be pretty in the middle pH-wise. And I think those are the only things that are coming to mind for me. But it's not directing me toward a clear answer of like, I'm sure the bath bomb is made of blah, blah, blah. I'm just not really sure.
You actually did very well. It is a reaction that's acid-base reaction.
Okay, nice.
So you nailed it on that. I could see why the Diet Coke and Mentos thing is kind of a nucleation is what they call it, where suddenly everything is finds a meeting point to be able to escape. All the gas molecules can come together and then escape really quickly.
Mm-hmm.
But in this case, it's actually acid-base.
Okay,
so good job. I'm proud of you. I like to have you guys spend some time thinking about stuff so that you can really, I guess, be invested in what is this everyday life thing that I just accept, you know?
Mm-hmm.
So we did talk about acid-base reactions before. Just to do a quick reminder. One definition of an acid is that it releases a proton. A proton is a hydrogen atom that's lost its electron.
Mm-hmm.
So it's just a proton hanging out in space, basically. And once something loses electrons, it usually wants them back if it can find it. And that's why bonds form, is they are actually sharing electrons, or the electron attraction with a negative and a positive come together.
Mm-hmm.
So in this case, your hydrogen atom in an acid has lost its electron and it wants to find them again.
Mm-hmm.
And I told that joke that my cousin made up, or maybe just heard somewhere, where the way you remember if it's negative or positive is a cation runs into a bar and says, I think I lost an electron. And the bartender says, are you positive? That's how you can always remember what happens when you lose an electron. So we've got our positive proton floating around, and it's on the hunt. It's like looking around for its electrons.
Mm-hmm.
And it finds electrons usually in something that's basic.
Mm-hmm.
Bases have an excess of electrons usually. But the problem is, in a bath bomb, you have both an acid and a base. You have baking soda is usually what the base is, and citric acid, which is also the acid, that's in citrus fruit, so it's safe in good quantities. And I'm sure if you took a ton of citric acid, that wouldn't be good. But in measured quantities, citric acid is safe.
Uh-huh.
So you have your base and your acid, but they are kind of stuck where they're at because they're in a solid form. So even though they're looking for something else with electrons, they can't move over to it.
Mm-hmm. Mm-hmm.
There's not space for the atoms to move around and find each other.
Got it. Okay.
So when it's just sitting there on your shelf, there is acid and base present in a bath bomb.
Uh-huh.
And it's like stuck. It's frozen.
Uh-huh.
And then you drop it in your bath. And the acid and base are now in water. And so they have the mobility to move around and come in contact with each other and cause a reaction to happen.
Wow. Okay, got it.
So once they get in the water, they're moving, they're grooving, they're finding each other.
Mm-hmm.
Okay, so then when they find each other, the proton finds something, it's lost electrons, it finds something with extra electrons. The reaction happens and new things are made.
Got it.
And in this case, when the proton finds baking soda, it creates carbonic acid.
Mm-hmm.
And carbonic acid will very quickly then rearrange to form water and carbon dioxide, just like you said.
Nice.
And so we've talked about that before. It also happens in your sodas. Carbonic acid has everything it needs in it to make up water and carbon dioxide. So it will very quickly form carbon dioxide, and the carbon dioxide will float away in the form of fizzy bubbles.
Nice. Dang, dude, I was like pretty uncertain about those two things. They seemed, I think, a little bit like, okay, these are just the guesses I even have in my tool belt. I don't have much beyond this that I can muster up. So,
well, good job.
Dude, sweet. Those are cool. That's awesome.
I know. I think it's really cool. It also is the same reaction that happens when you drop Alka-Seltzer into a cup of water. It happens in your soda cans, and it's, like you mentioned, baking soda and vinegar. It's a different acid in terms of baking soda and vinegar. Baking powder is got a solid acid in it. It's also a different acid it has in there, but all of those things are baking soda finding an acid, making carbonic acid, breaking down to CO2 and water, and releasing bubbles.
Got it. Nice.
In your volcanoes, in your Alka-Seltzer, in your baking powder, and in your bath bomb.
Nice. Dude, awesome. That's cool.
So do you want to take a stab at explaining that back to me, and then I'll give you another fun fact?
Yes. One image came to mind for me while you were talking about that, which I guess is not the first time we've talked about things kind of existing already together and they just need a way to interact, you know?
Yes.
This isn't a perfect analogy, but I started thinking about the way that you can buy yogurt where it has like two compartments and there's like yogurt in one and then like some fruit flavoring or even just some granola in another compartment.
Yes.
And basically it's like, yep, they're right here, we're right next to each other. But you are that missing piece to remove the thing and then dump, like just kind of flip that little other compartment over.
Right.
And so it's kind of like bath bombs already have that. They're packaged together. There just is no way for them to interact as they currently are.
Right.
It requires something very outside of what it is to do that. And water is perfect for that. So immediately when you drop it in, things can start happening and interacting. In the case of yogurt, it's just a delicious experience we all have. But in the case of a bath bomb, it's a fizzy, like good smelling, colorful, cloudy experience that we have.
That is exactly right.
That was like basically not at all sciencey. But
well, you kind of avoided the recap of the proton acid base situation. So do you want to try to do that a little bit too?
Yes.
Before you do that, I guess I do want to say that this is insight into what's going on at the molecular level. I know that doesn't feel very sciencey or whatever, but I think molecules can just seem really abstract. You know, we don't really know what's going on. And so to know that they can't always come into contact or interact unless they have some kind of mode of transportation, basically is kind of good information, you know?
Right.
I think we want to think, oh, you just put an acid and a base together and boom, a reaction happens, but clearly it doesn't, you know? And I do think that's good insight. And that's why we put solvents into reaction vessels. You know, if I put just a bunch of powders into a flask in my lab, nothing's going to happen usually until I add the solvent. But there is an area of chemistry that's trying to minimize the use of solvent known as green chemistry, because it can be kind of wasteful to use so much solvent in reactions. So they're trying to work on optimizing that to be better for the environment. So even though it doesn't feel very sciencey to talk about the mode of transportation, the flipping over of the yogurt, filling into the cup, it is still good information and insight to have. We are learning about how molecules work when we realize that they need, you know, a molecular highway to go on, kind of.
Yeah. Okay. Yeah, that makes sense. So I know, man, I always trip myself up a little bit about trying to remember which one is which one has lost an electron, which one has lost an electron and is now positive. my gut wants to tell me that's an acid.
That's right.
Okay, cool. I think I should overthink it.
Yeah, there's not a good trick for that. If you're trying to remember some other stuff about acids and bases, there's ways to do that, but there's not a good way to remember that acids give protons. There is a different definition of that in Lewis acids and bases, where the Lewis acid, it's missing electrons, so it's known as an acceptor. So you can maybe think of that acid acceptor. It's going to accept electrons because it's missing them.
Got it.
That could get you more confused. So it's kind of a different definition. We don't have to go into that.
Okay. So the acid is positive. It's lost an electron, which means it's positive, and it's a cation.
Yes.
And that means that if given the opportunity to take on some electrons from something else that will give them, then it wants that. So it is a star-crossed lover. It is a unrequited love. It is like, I'm lonely, I need, or whatever. And once that, if it can be combined with the right substance, and bases are perfect for that because they've got the opposite thing going.
Yes, they have extra electrons. So really when they come together in a covalent bond is what it's called, they're sharing electrons. So the hydrogen atom, it's almost like holding hands. It has access to those 2 electrons, and the base is now giving its extra electrons to be shared with someone else. So one person has too much, the other person has too little, then they form a partnership and they can share.
Nice. If only societies were like that. And then we get this really great, very positive, consensual situation going on in our cakes, in our baths, in our volcanoes, in our Alka-Seltzer and waters stuff.
It is a good situation, but I would hesitate to use the word positive situation.
Oh, that's true. Good point.
Because it's a neutral situation.
That's so funny. I just quickly used that word again in a very non-chemistry way. Just like, it's so funny how everyday it is, but it's like, oh yeah, no. Here, positive means something, and we can't just throw that word around.
Yes, that's exactly right. So you've got your proton, which is looking for something, your base, which has extra of something, and then they meet in the middle and share the something. Dude,
awesome.
Ooh, it'd be like if you baked too many cookies and you didn't want to have them all for yourself because that makes you feel bad and, it's not really stable. So then you call your friend over who was craving a cookie, and then you can share them.
Nice. And then you're both happier. It's like, I would probably feel sick if I ate this many cookies. And you would feel sad if you had no cookies.
Yes.
So why don't we both have a normal amount of cookies?
Yes. That's not exactly right because you're not like literally sharing one cookie the way the 2 electrons are shared, but I think that's a good analogy. So that's kind of how bonds work. And I like to think of them as holding hands. There's different kinds of bonds. Maybe we could get into that at some point, but this kind of bond, really, they're sharing the electrons, and then quickly, once you have carbonic acid, it can break down into the carbon dioxide and water. And if you want to learn more about how that happens, go check out our episode on, I think we talked about it in the difference between baking powder and baking soda. I remember making a video where I rearranged the atoms on paper, so I can also repost that as well.
Yeah.
Okay, Jam, well, you did really great. So I'm actually going to give you 2 fun facts. One I forgot to mention earlier, and then a second one.
Okay.
The first fun fact. You may notice that bath bombs leave behind color or fragrances or whatever going on in them. So that's actually just mixed in additives. So you could have a pure bath bomb that's just citric acid and baking soda. I always want to say baking powder. Just citric acid and baking soda mixed together and pressed into a shape in an egg. There's actually a chemistry experiment where they make their own bath bombs. But if you want them to be more colorful, you can add a few drops of food coloring. You can add Epsom salts as a filler. You can put cornstarch in to help them bind a little bit more. You can add skin safe, make sure that they're safe, essential oils to give it some of that fragrance, or you can add some moisturizers, like a little bit of coconut oil.
Mm-hmm.
You can add all kinds of things to your bath bomb to be a transporter of good smells, good feels, pretty colors in your bathtub.
Nice.
So that's one fun fact. So I know we can't talk about how bath bombs work without asking how they turn our bath watercolors.
Yeah.
And then our second fun fact would be, so reactions need energy to happen. You have to put energy in generally to make a reaction happen.
Mm-hmm.
And in this case, because we are using warm water as the reaction, quote unquote, vessel, that has more energy in it because the heat, is warm. That's a form of energy than if you were to put cold water.
Mm-hmm.
So if you were to take a nice warm bath compared to an ice bath, your bath bomb should have more of a fun effect, go a little bit faster, be a little bit fizzier in the warm water than it would in the cold water.
Dang, yeah. Wow, interesting. And also funny because almost every bath is warm, so it's that you'd easily not think about.
Well, I think if some people take ice baths after they work out and they get all sore. So maybe they can test it out, or maybe this is what I'll do. You could do a bowl of ice water and a bowl of hot water and drop a bath bomb, same one by two, in both, and do a little science experiment. Or maybe I could even make a little TikTok of that, which brings us perfectly into my happy thing from this week. Someone convinced me, my friend Caitlin, shout out, listener of the show, convinced me that TikTok would be a good way to communicate science in a different platform and maybe reach different people. So I've been making little science videos on TikTok, and it's been really fun. Some of them are little experiments. Some of them are explanations, but it's been really fun so far.
Dude, nice. Yeah, I think we both had our hesitations about TikTok, but
yes,
I think Caitlin was right.
Yeah.
So, yeah.
It definitely has sucked a lot of my time up, and I've had to put a time limit on that app so that I don't spend a million years on it, because people are just really smart and funny and creative, and those videos are really good. But I do think it's reaching people that you wouldn't normally reach, and so that's really fun, and it's a quick, easy way to share some science facts, which is fun. And I think I'm going to use it as a platform to maybe do some chemical misinformation, like we talked about last week with the vinegar being chemical free type stuff. So we can speak into that on a platform where it's quick and bite sized,
Nice. Yeah, totally.
So I'm excited about that. So that's my fun thing for this week. Do you want to share yours real quick?
Yes, absolutely. So real quick, my son is starting to get where he's trying to say stuff, and that's been really fun. It's a lot of, just gibberish and stuff, but a couple sounds have kind of come to the forefront that he likes to make a lot, including dada, which is really fun. And hopefully we can try to teach him that it means something, because that's what I think is so interesting right now, is he just figuring out making sounds and what he can make. And so he's said dada a lot now, but does not know yet what he's saying. So
right.
He'll say it to anybody.
It's still very cute, and he is getting cuter every day. The other day, I'm going to change my happy thing from this week. The other day, Jam sent a picture of him sitting in a laundry basket. He has a big smile, and he just looks so cute. I lost it. I was like, he's so cute, and just could not stop looking at that picture. It was so adorable. So
yeah, he definitely is. I agree. I mean, I'm certainly biased, but I 100%, 110% agree.
Very cute. Can't wait to hear him say mama.
Yeah, we're hoping that comes soon as well. So, and then we can try to get him to know those are different things and they mean different things and all that stuff. So
I think that'll come before we know it. I think it's going to fly by. The fact that he was born during the pandemic and he's grown so much already, and I haven't really gotten to see him and hold him and know him and interact with him.
Yeah.
It's crazy how much he's learned in this amount of time so quickly.
Yeah, it's really crazy. It's very weird.
Well, thanks, Jam, for sharing your cute baby stories with us. We are so happy to hear anything cute like that. We all need good news these days. And thanks for coming and learning about bath bombs. And thanks to all of you listeners as well. And definitely try some chemistry experiments out with them. Try them in hot water, cold water, see what you can find.
Well, thank you so much for teaching us and for making bath bombs interesting, even for those of us who don't use them as often. I think they're still super cool to learn about. Melissa and I have a lot of ideas for topics of chemistry in everyday life, but we want to hear from you. What things do you wonder about? What daily household things do you use that are probably chemistry? Please ask us. You can email us on Gmail, or you can tweet us on Twitter, or gram us on Instagram, or book us on Facebook. Book us, or you don't have to face us. You can just book us. I think that makes more sense. At Chem for Your Life. That's Chem, F-O-R, Your Life, to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the costs of making it, go to ko-fi.com/chem4yourlife and donate the cost of a cup of coffee. If you're not able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to be able to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. References for this episode can be found in our show notes or on our website. Jam Robinson is our producer, and we'd like to give a special thanks to V. Garza and A. Collini, who reviewed this episode.